All right, welcome back. We are going to be talking about rational exponents today. We've been working all chapter on exponents and we've seen all kinds of different rules. And today the calculations we do aren't going to be too hard. I just kind of want to show you another way to write exponents and write square roots and just do a couple calculations with those. So let's get started. The first problem is x to the 1/3. And we've done some stuff with exponents that are fractions. So we shouldn't be scared of something like this, but I want to kind of show you just another way to write this. We can use this. This is written in exponential form. We can write this in radical form. And a radical, you may have never heard of a radical before, but you've used it certainly. A radical is just a square root sign. Okay, so if I want to write this as x to the 1/3, how am I going to do it? First of all, I'd like to draw your attention to this down here. The square root of x is x to the 1/2. All right, it's the same thing. Potato, potato, it's just another way of saying it. Now, a square root means we're looking for two numbers that multiply to get something. So the square root of 9 is 3 because 3 times 3 is 9. So a square root, we're looking for two numbers. So there's kind of like a 2 out there outside the radical. Okay, so the second root of x, or the square root of x, is equal to x to the 1/2. So with that thinking in mind, if we come up here and we look at x to the 1/3, that's just going to be the same as saying the third root of x. That means what times what times what is going to give us x. And let's look at the next one. 27 to the 1/3, we could rewrite that as the third root of 27. So what times itself again is 27. And we can actually evaluate that. That's a number that's not too hard to see. Something times itself again is going to be 27. That answer is going to be 3. 3 times 3 times 3 is going to be 27. All right, let's look at the next one. The fourth root of x. This is written in radical form. Let's write it in exponential form. So the fourth root of x, that's just the same thing as saying x to the 1/4 power. The radical form of the fourth root of 16, we could say that that's the same thing as 16 to the 1/4 power. And this one we can actually evaluate. Something times itself again is going to be 16. Can you figure out what that is? That's going to be the number 2. All right, the fourth root of 16 is 2. 16th to the 1/4 power is 2. Just same way, two different ways of saying the same thing. Let's look at these next ones. This is going to get a little bit harder. X to the 2/3. Well, I actually have it written down there already. Remember what we had before I said that the square root is like the second root of x because we're taking two numbers times themselves? Well, the third root of x, that's going to be x to the, I'm sorry, the third root of x, that's the same thing as saying x to the 1/3 power. All right, so that's very similar to what we see up there, but instead of the 1, we have a 2. Well, we're going to solve that problem by putting a 2 with the x inside the square root. Okay, so maybe that makes sense. Maybe this is just a pattern that we kind of have to see, but the x to the 2/3 is the same thing as the third root of x squared. All right, same thing to do there. Okay, 27. Let's see that. 27 to the third root to the 2/3. So that means that's the third root of 27 squared. We can actually calculate this. The third root of 27 is going to be 3. And if we square that, that's just going to be a 9. 3 squared is 9. So 27 to the 2/3 power is going to be 9. So let's look at this next one. This is written in radical form, the fourth root of x to the third. Let's write it in exponential form. This is just going to be x to the 3/4 power. X to the 3/4 power. Let's look at this next one. How would we rewrite this using exponents? This is going to be 5 to the 7/4 power. 5 to the 7/4 power. I have no idea what that's going to be, but that's how we would write it. Last thing, let's actually do some basic calculations with these problems. So 25x to the 1/2, and we're going to kind of simplify these and write them in radical form. So we're going to use the square root sign. So 25x to the 1/2, here's what I want you to see. The only thing that's being taken to the 1/2 power is the x. So this answer is just going to be 25 root x. Okay, easy enough. Now look at the difference between the next one. The next one, the 25 and the x are being taken to the 1/2 power. So I need to take the square root of both of those. Well, the square root of 25, that's not bad. That's just 5. And then we would have the square root of x is just the square root of x. Okay, so see the difference there. On the top one, only the x is going to the 1/2 power. On the bottom, the 25 and the x are going to the 1/2 power. So we have to take the square root of both of those. So make sure you see that difference. Subtle difference in the way it's written, but a big difference in the answer, as you can see. Okay, so what are we going to do with this down here? Well, we've been using the exponent ladder the whole time. This is asking us to multiply, right? So we're going to start with multiplying the numbers. There's no numbers, there's no coefficients there. And we have to climb a level and do that with the exponents. So all we have to do is take 2/3 plus 1/2, 2/3 plus 1/2, adding those exponents. And if we change these, because we got to get a common denominator, this looks like it's going to be 4/6, multiplying by 2, multiplying this one by 3 is going to be 3/6. Whoops, 3/6. So that answer, when we add them together, is going to be 7/6. So back to this problem, this whole thing, all we have to do is add the exponents. This is just going to be x to the 7/6 power. Okay, so we're not getting crazy yet with the calculations that we're doing, but it is important to see the way that exponents and radicals kind of work together and can weave back and forth and in and out of one another. All right, I know you got it. Good luck.